I'm using this Ziteboard um, whiteboard that I paid for because it's easier for me to bring images in, and I'll probably be doing some graphing stuff with you guys at some point, and it's so much easier to do if I don't have to actually draw the graph every single time. So that is the purpose of this. Um, so trigonometry, it literally means the measurements of triangles, right? Triangles and their measurements. And triangles are kind of the basis for everything. Like the strongest shape in the world is a triangle, right? Which is why we use it to like brace everything. Like you ever notice like we don't build anything that's just like squares without like braces to kind of make those triangle corners stronger, because that is like the main form of support that we have. It's why pizzas are triangles. Illuminati confirmed. Um, One thing to think about when we're talking about angles, which is really what we're talking about today, is that angles have two sides, right? Ultimately, when you have an angle, oh, where'd it go? Oh, the pen's not on, that's why. So when you have angles, anytime you have an angle, you have what we would call an initial side, and you have a terminal side, right? And when you think about it, terminal, like it terminates, and when we look at angles in general, we usually count counterclockwise. We measure counterclockwise. So this would be your initial side. Man, my pen's got like all these buttons activated on it right now. So if this is your initial side, you're going to measure in that direction, right? This would be your vertex right here. We'll call it V. This is your initial side, and this is your terminal side. And if you saw it in terms of a graph, like the standard position of an angle, let's put it in a good color that it'll stand up, is it starts on this line, and then we measure it in this direction. Right? So like if we went up to here, it would be 90 degrees. If we went all the way around, it would be halfway around, it would be 180, and then we'd have 270, and then we'd have 360, right? But when we're talking about the angles themselves, usually we start the count on this line right here, which would be normally our x-axis, right? That is where we'd start the count, and that would be 0 degrees right here, and then we would measure the distance, like 30, 45, 60, 90, 120. Look, it just made them for me right there. And that's kind of how we deal with angles, right? We've got the standard position. The standard position is starting at 0 and counting counterclockwise. Um, Negative angles, so when we're counting a positive angle, we're counting counterclockwise from this point. If we have a negative angle, we're counting clockwise from that point, right? So negative counts in this direction, positive counts in that direction. So when we're talking about degrees and stuff like that, that's what we're talking about. And that would be an angle in the standard position. So, and if we did that, like I said, if this angle was on the line, right? This one right here was, ooh, dang man, I don't know why it keeps turning off. If this was our initial side that started at 0, when we got to the other side, it would be terminal. If we started from this point though, this angle that goes all the way around and meets it, because yes, this is an angle, right? But this in the negative is also an angle, right? It's just that this is still the initial and this is still the terminal. We're just going in the negative direction. So every angle has a coterminal angle, right? So if I have this angle right here, and we say that it's 30 degrees, right? This one. If I go this way and I go all the way around, its coterminal angle would be 330 degrees. Why? Yeah, because all the way around a circle is 360 degrees, right? So if I have a coterminal angle and it's 30 degrees, like I have an angle and it's 30 degrees, its coterminal angle is just going to be 360 minus 30, right? Make some sense? Sometimes you'll get an angle that says like 420 degrees. And what is its coterminal angle? In that case, you're going to subtract like 360. I'll show you. We'll get to it. I don't want to say it. I'd rather show it to you. But that's what I'm talking about with coterminal angles. Okay, I covered that. Positive, negative, coterminal. The next thing we want to talk about is radian measure. Does anyone know what a radian is? I think this is like one of the first times we're bringing in the concept of radians in math, is in pre-calculus, unless you took a trigonometry class back in the day. Some of you might know it because sometimes you get like a little touch of the sine, cosine, and tangent in geometry. Like they give you a little taste of that, but there really isn't much of a reason to go into the difference between radians and degrees when we're dealing with it. It's just that introduction of pi for you. A radian is, let's see, well, I can tell you what the actual definition of the radian. A radian is the measure of a central angle that intercepts an arc equal in length to the radius r. I'm just reading it to you because I don't need you to know the exact definition, because I'm going to show it to you in pictures. So 1 radian is the measure of a central angle theta that intercepts an arc s equal in length to the radius r of the circle. Algebra. Okay, what does that mean? It means a lot. Say I have a graph. Say I didn't blow this thing up to 500 times what it was. Got a graph. No, I got a graph because I put one here. So here's a graph. Pretend there's no numbers on this graph, or don't. Say I've got this circle. But yeah, pretend there's no numbers on it. We're just going to make everything a unit of 1, right? And pretend I'm drawing a good circle here, right? Pretend that's a good circle. What we're saying is that a radian is, if I have this central angle right here, right? I have this angle that we're calling theta, right? And it goes from here to here, right? We're saying that we are drawing the radius, the angle, the length of the radius. So this S, this arc, S stands for the arc right here, which is this distance to here, right, is the arc of the angle. And they're saying that it is equal to the length of the radius, right? Because think about this, every point on that circle has the same radius, right? The whole idea of a radius is that you start at the center point and you go to the end of the circle, and every point is the same distance away from the center, right? Because that's kind of how a circle works, right? If I have a center piece, every point on that circle is going to be the same distance away from the center because that's how centers work, how circles work, right? And we're saying that a radian is if we take the length of this radius right here and we wrap it around the circle, right? And so let me change color so you can kind of see what I'm getting at here. So this whole section right here is 1 radian, right? And if I did another radian, that would be 2 radians, right? 1 plus 1 is 2. And then we would have, say, 3 radians. And then this little area right here between here and here would be like 0.141596 forever and ever radians. Because the distance between here and here, we know it is 180 degrees, right? But it is also equal to pi. So that distance from here all the way around here is pi. And pi is 3.141596 dot 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 forever and ever, right? So that's where pi comes from. It is the distance halfway around the circle. Now, if we went all the way around the circle, I'm drawing terrible pictures, we would have 2 pi. Does that make some sense? So the whole idea is if I have a radian, right, that theta, we're saying that this distance, this s, is equal to r. That means, what does that mean? It means our arc length, this is our arc length, equals the radius. That's the main thing to remember about a radian. It's when you're wrapping it around the circle and your arc length is equal to your radius. That's it, the length of your. There is a formula for this that is a definition of radian. This theta right here, if we want to know what that central angle is, that theta is equal to S over R. That's it. Let's play with this a little bit so that we have more than just a definition so that we can kind of see. So we talked about 1 radian, 2 radians, 3 radians, and it's equaling a circle, right? Total of 6 radians and a little bit more equals a full circle, right? Because 3 plus a little bit more gives us a half circle. 6 plus a little bit more gives us a whole circle, right? So like a half revolution is pi, full revolution would be 2 pi. Measure an angle, full red, blah, blah, blah. I'll get into the rest of that later. I think I don't need the rest of that right now until we get to unit circle. What it does allow us to do is we could tell what quadrant a radian's going to be in the same respect that we can with a regular circle, right? Like if I'm using angles, and I know I have a graph up there and I'm still drawing it by hand because I just think it's easier because it doesn't move on me when I draw it. So if I have, say, my circle here, right? Pretend it's a circle, pretend this is the center, pretend that I drew it well, right? I'm struggling today with my tech. If I think about this, right, here we have 0 degrees, right? And here we have 90 degrees, right? And here we have 180 degrees, and here we have 270 degrees. Because if you think about this, this is 360, right? And if I divide it by 4, I get 90. If I divide it by 2, I get 180. If I divide it by, like, each piece we know is 90 degrees, right? So I've got 90 degrees to here, another 90 degrees to here that gives us 180, another 90 degrees to here gives us 270, and another 90 to here we get 360, right? If we think about that in terms of radians, here we have 0, and here we have pi, right? So here we have halfway between 0 and pi, which is pi over 2, right? Here I have pi. So if this would be adding like another pi over 2, right? I would be going pi plus pi over 2. Does that make sense? Right? If I add another 90 degrees, another pi over 2, half a pi, here I would have what would break down to be 3 pi over 2. Here we have 4 pi over 2, which is just 2 pi. I like to think of it when I am thinking in terms of how these play out. I always try and do the math halfway, like to between 1 and pi. Like if I'm breaking it into 2 pieces, right here, I know that like this is pi over 2 because I broke it into 2 pieces. So this is 1 piece, and this makes, whoops, sorry, this makes it really big. And this would be pi, right? So pi is pi over 2, right? Which is like 2 pieces, right? This would be like, this is like 2 pi over 2, and you get pi. This would be 3 pi over 2. This would be 4 pi over 2. And no matter what length I'm breaking it into, if I broke this triangle down into 6 pieces, the first piece would be like pi over 6, which is like 30 degrees. And then 2 pi over 6 would be 60 degrees. And then 3 pi over 6 would be 90 degrees, which if you break down 3 pi over 6, like if you reduce that fraction, you get pi over 2. We don't need to get into that. I just get a little excited sometimes, so I just kind of wanted to explain that piece of it. And the only reason I'm getting to it is because you know how like when we have 0 to 90, we call that quadrant 1, right? This is our quadrant 1 when we're talking in terms of degrees on a Cartesian plane, right? We would call this this 1, and we would call this quadrant 2, and this quadrant 3, and this quadrant 4. And what we know about those things is like here everything's positive. X and Y is positive. When I'm dealing with degrees, when I'm dealing with points, either way, this section, everything is positive. This section, our x's are negative, but our y's are positive, right? If you remember this, like if we have x, y, this is positive and this is positive here. And if you have x, y, we know that x is negative and y is positive. And here, what do we know? We know that um, everything's negative here. It's like talking to one of my kids. Everything's negative. And here we've got plus and minus, right? And there's certain things we know about those quadrants. We know that everything from 0 to 90 degrees is positive. So any angle measure from 0 to 90 degrees, we know is going to fall in this section, right? We know that every angle measure from 90 to 180 is going to fall in this section, right? In quadrant 2. And we know that every degree from 180 to 270 is going to fall in quadrant 3. Does that make sense what I'm getting at? So in terms of radians, that still kind of plays out, only we're not talking about degrees anymore. We're saying that any theta, any angle between 0 and, so we're saying any theta between 0 and pi over 2 fits in this quadrant. And then any theta from pi over 2 to pi falls in this quadrant, right? And so this one, we're going to say from pi, I don't know why I drew a line over it. Here, we'll turn this to 3 pi over 2, and we'll go theta. I'm just going backwards. Why? Because I screwed up. So from pi to 3 pi over 2 is going to be in quadrant 3. And then we've got 3 pi over 2 less than theta less than 2 pi. So given a radian, you can always tell what quadrant it fits into, right, based on whatever that fraction is. Because when you're given a radian, it's going to usually have a pi value, right? So here's the thing. Like, you're not going to be asked a question about this likely in your homework. You might. There might be like one or two that say, like, what quadrant does this value lie in? And you just have to know, like, if you can kind of get that picture in your head of where the quadrants lie. I feel like maybe I should post a picture of it into Google Classroom too, so that you guys have access to that. And you can just kind of click on it and see where all of it is. Eventually I'll have a full unit circle going on with all of that stuff. So why am I telling you about this? Because I've already told you about coterminal angles, right? Like if I have an angle that starts one side, it's going to have an opposite angle going in the other direction, right? They have the same starting point. They have the same ending point. So when we're dealing with coterminal angles, we need to kind of have to know how to deal with these like pieces of pi, like literally pieces of pi. So they're coterminal. What did we say? So coterminal angles. Coterminal angles have the same initial and terminal sides. It doesn't matter which direction I go, right? If I have, right, if I have an angle that's like this, and this is my initial side, and this is my terminal side, it doesn't matter if I'm going this way or this way, they still start and end in the same spot, right? Which is what makes them coterminal. They have the same initial spot and they terminate in the same space. So what does that mean for you guys? It means that if I have a positive angle, say, say I have 13 pi over 6. So, gosh, man, I can't even every single time I keep hitting this. So if I have a positive angle, man, my handwriting is terrible on this whiteboard. Positive angle, 13 pi over 6. And I want to find at a coterminal angle. All I have to do is subtract 2 pi. So when it is a positive angle, we can subtract 2 pi and we will get our coterminal angle. Now, how do I do that? I got 13 pi over 6, and then I've got minus 2 pi. Got to find a common denominator. The good news is there's only one denominator, right? Showing right now it's 6, so we'll make our common denominator 6. So this would be 13 pi over 6 minus, well, 2 times 6 is 12, so we'll go 12 pi over 6, and we wind up with pi over 6 is where our terminal angle will be. What does that look like? Well, if I had a graph of it, right, and I had this circle here, it would be like if I broke this half up into 6 pieces, and this would be like pi over 6 would be 1/6 of it. It would equate to about 30, it's not even about, it would equate to 30 degrees. Think about that. If I have 0 to 180 and I divide that by 6, that's a 30-degree angle, right? If I have 0 to pi and I divide that by 6, each piece is the length of pi over 6, 1/6 of pi, right? Because all the way to the side there, right, all the way from here to here equals pi, right? So I know that this would equal 1/6 of pi, right? So the coterminal angles would be the coterminal angle of 13 pi over 6 is pi over 6. Does that make sense? So 13 pi over 6 is our positive angle, and pi over 6 would be our terminal angle. Did I explain that well? Did you kind of get that? Now, if it's a negative angle, given a negative angle, we're going to say I have a negative angle, -2 pi over 3. To find the coterminal angle of a negative angle, we're going to add 2 pi, right? For a positive angle, we subtract 2 pi from it. From a negative angle, we add 2 pi. So same thing, though, is going to happen. We've got to have common denominators. We only have one denominator. It's 3, right? So we're going to make the other denominator 3. So we're going to have minus 2 pi over 3 plus, well, 2 times 3 is 6, so plus 6 pi over 3. Minus 2 plus 6 gives us 4 pi over 3, and that's our coterminal angle. Make some sense? Not too hard, right? If you're given a negative angle, you want the coterminal angle, you add 2 pi. If you're given a negative, positive angle, you subtract 2 pi. trying to, I feel like I'm not getting to the end of it because this class is almost over. I'm going to have to adapt your guys' assignment. We have 6 minutes. Is that what you said? So in your assignment, when we're talking about coterminal angles, you'll usually be asked to find two, one positive one negative one, right? So if I feel like I missed a section. I feel like there's a little section in my notes missing. Minus 2 pi over 3. Okay, so if I am given, it's like it just decides it wants to stop writing. If I'm asked to determine two, so many technical difficulties today. Determine, okay, I'm just going to say it. Determine two coterminal angles, one positive and one negative for a theta equals 9 pi over 4. To determine the positive one, we're just going to do 9 pi over 4. Sorry, minus 2 pi. And to determine the negative one, we're just going to take our 9 pi over 4 and subtract 2 pi. Right? So we go, okay, one will do plus 2 pi, and then the other one will do 9 pi over 4 minus 2 pi. Does that make some sense? Now, for the one where we're adding 2 pi to an already positive angle, you have to think about kind of how a circle works. You're going to get something that's bigger than 2 pi. But when you think about a circle, right? If I have a graph, right? And on it, I have an angle, right? We'll make, say this is our angle, right? If I get to this, say this is my theta right here, right? And I add 2 pi to it, it's going to just go all the way around the circle again and end up here. But think about how circles work, right? If I can do that, like say this is 60 degrees, right? We'll just pretend it's 60 degrees, right? If I go all the way around the circle and come back to that point, right? That terminal point again, because I've added 2 pi to it, it'll take me right back to where I started. If we're talking about it in degrees and it's 60 degrees, that angle is now going to be 360 plus 60. Did that make sense? Like we took our 60 degrees and then we added another 360 degrees and we're going to have like 420 degrees. Well, that kind of works with pi as well, right? With radians as well. So we determined that that that's 60, this right here, like 630 degrees was pi over 2, and then 60 degrees was pi over 6, and then this was 2 pi over 6, which is the same as saying pi over 3, right? So if I have pi over 3 and I add 2 pi to it, right? I'm still going to wind up, I'll have what seems like a bigger number, but it's still going to take me right back to pi over 3. And so that is how, like, I can always have a positive and always have a negative. So like if I look at this 9 pi over 4 plus 2 pi, I'm going to make 4 my common denominator, right? So I'd have 9 pi over 4 plus 4 times 2 is 8 pi over 4, which gives me 17 pi over 4. And that is clearly more than 2 pi, right? Which is okay. This one, though, if I do it the opposite direction, I have 9 pi over 4 and I subtract 2 pi, that means I'm subtracting that 8 pi over 4, and I am left with this 8, just 1 pi over 4. So 17 pi over 4 and pi over 4 both end in the same spot. They just go from different directions. Did that make some sense? One is going in that positive direction, and the other one's coming back around in the negative direction. But either way, you're making a rotation based on 9 pi over 4. That is the end of class. I don't think I ever make it that far. Like I made it a long time. So sorry I kept you the whole time, but not sorry. It was kind of fun for me. But that is